Hello guys, welcome back to my channel. So my today's topic is BFS, which is breadth first search. So this is a very quick video in which I will solve an example related to a BFS. It won't be detailed one, so I won't tell you what BFS is and how it works. So it's going to be a very quick one. So to have the breadth first search of this graph, basically this is a sort of transversal mechanism in graphs. It is implemented basically only in graphs, and there's another transversal mechanism that's called DFS, and in BFS it is implemented with the help of a queue. I hope you guys already know what a queue is, but for those who don't know what a queue is, just remember that queue has two ends. One is a front end and second is a rear end. Insertion is take place at the rear end and the deletion take place, or we can say the DQ take place from the front end. So we start BFS from the starting node. Here I'm taking the starting node as 1. So in BFS we always enqueue the starting node. Here I'm enqueue the 1, and along with the 1, and then we DQ the front node, and after that the front node, all the adjacent nodes related to the front node are enqueue in the queue. So this is the mechanism of BFS. This is how BFS works basically. We keep on enqueuing the adjacent nodes of the DQ'd node. Okay, and this continues until all the nodes are get visited. So here I have visited the node 1 and I'm going to DQ it, and when I'm going to DQ it, my BFS first term will be 1, and it's adjacent all the nodes, the 4, 2 and 3, they will be enqueued, and it's up to us that how we're going to enqueue it. Either I can enqueue 4 2 3, or I can enqueue 2 3 4, in any order I can want, but here I'm going to go in the topological this order way. So it's going to be 2 3 and 4. Sorry, 3 is not adjacent to 1. Sorry, my mistake. 3 is not adjacent to 1. Only 2 nodes are adjacent to 1. They're 1 2 and 4. Okay, now after that I have to enqueue another front, and because my front will become this, and DQ the other front, and my 2 will come out, and I have to enqueue its adjacent nodes. So the adjacent nodes related to, now here 1 is visited, and I have visited to 2 2, and so adjacent nodes are 3 and 5, 7 and 8. So I'm going to enqueue them in the topological sort again, 3 5 7 8. We only enqueue those nodes who are not visited yet. Okay, so my front will become this now after the DQ operation. Now after the enqueue has been done on all the nodes adjacent to the 2, I will DQ the front again. Here the 4 will be DQ'd, so my the front will become 3. So here this 4 has been DQ'd, it will become the BFS queue, and this is my BFS queue. Okay, so basically like this is my BFS. This is how this nodes will be printed out. Okay, this is a print pattern up here. Now after for the fourth node, this 4, the adjacent nodes are basically 3 and 1. The 1 is already visited, so we can't enqueue it into the queue, so only 3 is left up here. So we can see that 3 is already in the queue too, so we cannot enqueue it again, so the 4th is visited too. Now I have to DQ 3. My 3 will be printed out, and for the 3, its adjacent nodes are 10 and 9 only. So I'm going to enqueue them because they're not in the queue and they're not visited yet. So I'm going to enqueue them, and my front will become 5. So for the 5 will be printed out. For the 5 I have 6, 2 and 7 and 8. So my 2 is already visited, 6 is not in the queue, I will enqueue it. 7 and 8 are already in the queue, I can't enqueue them again. So my 5 is also visited. Now I will go to the 7th. For the 7th one, I will print it first, and for the 7th, so my 5th is also visited. For the 7th one, I have 8, 5 and 6 only. 8, 5 and 2. Okay, so my 2 is already visited, 5 is already visited, only 8 is left, and 8 is already in the queue, so I can't enqueue it. So I will move the front to 8. So my 8 will be printed out. Now for the 8 one, its adjacent nodes are 2, 5 and 7, and we can see that 2, 5, 7 already visited, so I will make it visited and I will move on. For the 9, my front will become 9, will become 9. So the 9, for the 9 one, this 9, it has only one adjacent, and that is 3, and 3 is already visited. So I will print just 9 and we'll move on to front. So here for the 10th one, again I can see that 3 is only adjacent node and it's already visited. So I will make the 10th visited 2 and I will print the 10th. Okay. Now next I have 6. For the 6 I have only one visited node and adjacent node, that is 5, and it's already visited, so there's no point. So 6 will be printed out as easily. Now my front end view, my front has, it's an empty queue, so I can't move further, and I can see that my all nodes have got visited 2. Each and every node has visited 2. So this is my BFS of this graph. Thank you.